Welcome back, everyone, for another deep dive. Today, we're going to be taking a look at blockchain technology.
Yes, we're going to be going pretty deep into blockchain today.
And I think it's going to be a really fascinating journey. Everyone listening already knows what a blockchain is,
Right.
but there's so much more to it than just, Bitcoin.
Absolutely.
So I'm really looking forward to getting into the real details.
Yeah, we're going to be exploring kind of the evolution of blockchain from its really interesting origins
Okay.
to where it is now, and I'm looking forward.
So where do we begin with this story?
Well, the story of blockchain begins in the early 1990s.
Oh, wow.
Before the term blockchain even existed,
Wow.
in 1991, Stuart Haber and W. Scott Stornetta, they were researchers at Belcore,
Okay.
and they were working on this system to try to ensure the integrity of digital documents.
So this is back when digital documents were really just starting to kind of take off.
Right. Yeah, it was the very early days of
Yeah.
the internet and digital technology. So they came up with this method of using cryptographic hash functions to create what they called a chain of timestamps.
Well,
So each new document would be linked to the previous one through a hash.
okay.
And this meant if any document was altered, it would break the chain and be instantly detectable.
So it's like a tamper-proof seal almost.
Exactly. Yeah, you could think of it like a digital fingerprint for each document.
That's incredible. And this was back in the early 90s.
It was, and this is kind of the very, very beginning of blockchain technology.
Okay.
But it kind of went under the radar for over a decade.
So then what happened?
Well, fast forward to 2008,
Okay.
we have the global financial crisis.
Right.
Trust in institutions is really low.
Yeah.
And this is where Satoshi Nakamoto,
The mysterious
the mysterious figure,
Yeah.
enters the scene.
with the Bitcoin white paper.
Exactly.
Yeah.
Nakamoto's white paper, Bitcoin, a peer-to-peer electronic cash system, proposed this revolutionary idea of a decentralized digital currency
Okay.
powered by blockchain.
So that was really kind of the first time that the term blockchain was used.
Yes, exactly. And the success of Bitcoin is really what catapulted blockchain into the mainstream.
Right, because then everyone started to take notice and look at the
That's-
technology itself.
Yeah, people started to see the potential beyond just digital currency.
Oh, okay.
And then in 2015, we have the emergence of Ethereum.
With a Vitalik Buterin.
Yes, spearheaded by Vitalik Buterin.
Okay.
And this is really key because Ethereum introduced smart contracts,
Yeah.
expanding the possibilities of what blockchain could do.
So going beyond just cryptocurrency.
Exactly.
Yeah.
Using blockchain for more than just
Right.
digital money.
So I think before we get into smart contracts, though, it's really important to understand how blockchain itself works.
Absolutely.
What is the fundamental structure?
Right. At its core, a blockchain is a type of distributed ledger. So it's a digital record of transactions
Mhm.
that's maintained across a network of computers
Okay.
instead of in a central location.
Instead of just on one computer.
Exactly.
Okay.
And so you can imagine it as this chain of blocks,
Okay.
and each block contains a set of transactions and a unique identifier called a hash.
Okay, so each block is kind of like a page in a ledger.
Right.
And the hash is like its unique fingerprint.
Exactly.
Okay.
And the key here is how these blocks are linked together.
Okay.
Each block contains not only its own hash,
Yeah.
but also the hash of the block that came before it.
Oh.
So this creates an unbreakable chain
Okay.
where if you were to alter one block,
Mm-hmm.
you would have to change all the subsequent blocks,
Wow.
which is virtually impossible.
So any attempt to kind of tamper with it
Right. It would be immediately apparent
would be obvious to everyone.
to everyone on the network.
Okay.
Yeah.
And this is where we get to this concept of mining,
Yes.
which is how new blocks are added.
To the chain.
So miners are the ones who validate and add new blocks to the chain.
Okay.
And they do this by solving complex cryptographic problems.
Okay.
And this requires a lot of computational power.
Okay.
The first miner to solve the problem
Mm-hmm.
gets to add the next block
Okay.
and is rewarded with cryptocurrency.
So it's not just about adding blocks.
Right.
It's also about securing the network.
Exactly. It's
Ah.
very resource intensive to
Yeah.
deter manipulation,
Mm-hmm.
but it's important to distinguish
Right.
between hashing and encryption.
Okay. Yeah, we hear those two terms thrown around a lot.
Well,
Blockchain.
They serve distinct purposes.
Okay.
Hashing, like we've been talking about, is creating a unique fingerprint
Right.
for each block.
Mm-hmm.
Encryption focuses on data confidentiality.
Okay.
So it's about protecting that information
Yeah.
from unauthorized access.
So hashing is like the tamper-proof seal,
Right.
and encryption is like the lock on the safe.
Exactly. A good analogy.
And encryption is used in a lot of ways with blockchain. For example, public and private key cryptography
Okay.
ensures that only authorized individuals can access and manage their assets.
So like my private key is what lets me unlock my
Exactly.
cryptocurrency wallet.
Right.
Okay.
But it's important to remember that even though blockchain itself may be secure,
Right.
the applications built on top of it might have vulnerabilities.
So it's all about the implementation.
Exactly. Security is a multifaceted challenge.
Yeah.
Now, how does a decentralized network with all these nodes participating
Right.
reach a consensus on which transactions are valid?
Yeah.
This is where consensus mechanisms come in.
Okay, so consensus mechanisms are really like the backbone
Yes.
of a decentralized system.
Exactly.
I'd like to explore that a little bit more.
Okay. So consensus mechanisms, they're really the elegant solution to allow decentralized systems to reach agreement.
Yeah.
Everyone on the network agrees on the order of transactions
Okay.
and the state of the blockchain.
Okay.
And this prevents any conflicts
Okay.
and maintains the integrity of the whole system.
So without a central authority, it's kind of amazing how these mechanisms can
Right.
establish that trust.
Exactly. It's all about coordination without a central point of control.
Yeah, so can we talk about some of the most like well-known consensus mechanisms
Yeah.
and how they actually work?
So let's start with proof of work.
Okay.
Or POW.
Proof of work, this is the one that's always in the news for its
Right.
energy use.
Exactly.
How does it actually work?
So in a proof of work system, miners compete to solve these complex cryptographic puzzles.
Okay.
And these puzzles require a lot of processing power.
Yeah.
The first miner to solve the puzzle gets to add the next block to the blockchain
Okay.
and is rewarded with the newly minted cryptocurrency.
So it's a race to see who has the most powerful computer.
Yeah, you could think of it that way.
Okay.
The fastest and most powerful computers will usually win.
Okay, so how does this make the blockchain secure?
Well, the amount of effort required to solve these puzzles
Right.
makes it really difficult for any single entity to control the network.
Great.
To attack the blockchain, you would need to control the majority
Right.
of the network's computing power.
Which is just not practical.
Right. It's not economically feasible for most attackers.
Okay.
So it acts as a deterrent.
Okay.
The cost of attacking the network outweighs the potential benefits.
But this is where the criticism of energy consumption comes in,
Yes, exactly.
because all of this computing power
Right.
uses a lot of energy.
It does, and that has led to a lot of research into alternative consensus mechanisms that are more energy efficient.
So like proof of stake.
Exactly. Proof of stake, or POS,
Okay.
is one of the most popular alternatives.
Okay. And how does proof of stake differ from proof of work?
So instead of miners competing with their processing power,
Okay.
in proof of stake, validators are chosen based on how much cryptocurrency they stake. So they essentially lock up a certain amount of cryptocurrency as collateral.
Okay.
And the more they stake,
Mm-hmm.
the higher their chances of being selected to validate a block
Okay.
and receive a reward.
So it's kind of like putting your money where your mouth is.
Exactly. It aligns their incentives with the health of the network.
Yeah.
They have a financial interest in acting, honestly,
Right.
and maintaining the blockchain's integrity.
And because there's no need to solve these complex puzzles,
Right.
it uses much less energy.
Yes, significantly less energy.
Okay, so it's a much more sustainable approach.
Right. It's much more environmentally friendly.
Are there any drawbacks to proof of stake?
Well, one potential concern is that it could lead to a concentration of power.
Okay.
If a small group of validators control a large percentage of the staked currency,
Mm-hmm.
they could potentially influence the network.
So there are still some concerns about centralization.
Yes, it's important to design proof-of-stake systems carefully
Okay.
to prevent that kind of concentration of power.
To make sure that it stays truly decentralized.
Exactly.
Are there any other consensus mechanisms that are worth talking about?
There are a few others. One is called Delegated Proof of Stake, or DPoS.
Okay.
DPoS, and in this system, token holders vote for delegates
Okay.
who are responsible for validating transactions and maintaining the network.
So it's kind of like a representative democracy.
Yes,
Very
exactly.
for blockchain.
Token holders elect representatives to act on their behalf.
Okay.
And this can lead to higher transaction throughput
Okay.
because the consensus process is more streamlined.
Okay.
But again, there are concerns about potential centralization.
Right, because if those delegates collude, then they could control the network.
That's right. So it's a trade-off between efficiency and decentralization.
It seems like there's always a trade-off.
There often is.
Yeah.
Mm-hmm.
Okay. Are there any other mechanisms we should mention?
briefly, we can mention proof of capacity,
Okay.
which utilizes hard drive space
Oh, interesting.
for mining instead of processing power. And proof of burn, where users burn their cryptocurrency
Wow.
to demonstrate their commitment to the network.
So they destroy their own cryptocurrency
In a way, yes.
to show that they're committed.
It's a way of signaling long-term commitment.
Wow.
And we also have proof of history,
Okay.
which uses a verifiable delay function to create a historical record of events.
Okay.
And this makes the blockchain more efficient.
Okay. And proof of authority, I think, is another one.
Yes, proof of authority relies on trusted nodes for validation.
Okay.
This is often used in private blockchains.
Okay.
So each consensus mechanism has its pros and cons.
Right.
And the best choice really depends on the specific needs
Okay.
of the blockchain.
So we've talked about a lot of different consensus mechanisms,
We have.
and they're all really important
Yes.
for decentralized systems.
They really are the foundation
Yeah.
of a decentralized system.
So choosing the right one,
Right.
it's all about balancing those factors. Yeah.
Exactly. You have to think about security, scalability, energy efficiency,
Right.
and the level of decentralization you want.
And I imagine as blockchain technology evolves,
Yes.
we're going to see even more
Absolutely.
innovative consensus mechanisms.
That's right. There's a lot of research and development happening in this area.
Now I want to talk about another really interesting aspect of blockchain, smart contracts.
Yes, smart contracts have the potential to revolutionize how we handle agreements and automate a lot of processes.
So how do they actually work?
Well, you can think of smart contracts as translating a traditional contract into lines of code.
Okay.
So it automates the execution and enforcement of that agreement.
So instead of having to rely on a third party
Right.
or, paper documents,
Exactly.
it's all handled by code.
It's all automated and it's all transparent.
Okay, so can you give us like a simple example of how a smart contract might work?
Sure, imagine a vending machine.
Okay.
You insert your money, you select a product, and the machine dispenses it. That's a very simple analogy, but it captures the essence
Okay.
of a smart contract.
You're defining the terms of the agreement,
Right?
and then the code automatically enforces it.
Exactly. And because it's on the blockchain,
Mm-hmm.
it's secure and transparent.
Okay. So what are some real-world applications of smart contracts?
Well, one area where they're being used is supply chain management.
Okay.
So you can track goods and ensure transparency at every step of the process.
So like if I'm buying coffee beans,
Right.
I can track them from the farm all the way to my cup.
Exactly. You can track the beans from the farmer to the transporter to the processing plant.
Wow.
And each step can trigger automatic payments,
Okay.
updates to inventory records, and even quality checks.
So it's all automated and transparent.
Exactly.
So there's no need to worry about someone tampering with the records.
Right. It reduces the potential for errors and disputes.
What about other applications?
Another big one is real estate.
Okay.
Smart contracts can streamline property transactions.
Because buying a house is usually a very long and complicated process.
It is very paper heavy,
Yeah.
but a smart contract could handle a lot of that,
Okay.
like verifying ownership, transferring funds, and recording the deed.
Okay.
And all of that can be done securely and transparently on the blockchain.
So it could potentially make buying a house much faster and easier.
Exactly.
Okay. What other applications are there?
There are a lot of possibilities. Voting systems,
Okay.
insurance claims processing,
Okay.
intellectual property rights management,
Wow.
even decentralized finance or DeFi.
So it seems like the potential applications are really limitless.
It really depends on our imagination and our ability to translate complex agreements into code.
But of course, there must be some challenges with smart contracts.
Of course, like any new technology, there are challenges.
Okay.
One is the complexity of writing secure code.
Right. Because if there's an error in the code.
Exactly.
Mhm.
Even a small error could have big consequences.
Yeah.
So it's really important to have thorough testing and auditing.
To make sure that the code is secure.
Exactly.
And then there's also the legal and regulatory landscape,
Right.
which is still catching up with this technology.
Exactly. The laws and regulations aren't quite clear yet
Yeah.
when it comes to smart contracts.
So there's still some uncertainty.
There is.
Okay. But despite those challenges, smart contracts really do seem like a game changer.
They have the potential to really change the way we think about agreements and automation.
Yeah. So moving on to another important aspect of blockchain,
All right.
privacy.
Okay.
It seems a little counterintuitive to talk about privacy
Right.
when we're talking about a technology that's so transparent.
It does seem like a paradox.
Yeah. How do we balance those two things?
Well, there are a few approaches that are being developed.
Okay.
One is using advanced encryption methods.
Okay. We talked about encryption before in terms of securing transactions.
Right.
How is it used for privacy?
Well, imagine a healthcare application that uses blockchain to manage patient records.
Okay, so very sensitive information.
Right, very sensitive.
Okay.
Encryption can be used to make sure that only authorized people can access those records.
So even though the data is stored on the blockchain,
Yes,
it's encrypted so no one can read it without the key.
exactly. It's like having a lock on a safe.
Okay. Are there different types of encryption?
There are.
Yeah.
We talked about public and private key cryptography.
Right.
That's one type.
Okay.
Another promising technique is homomorphic encryption.
Okay, I've heard of that, but I don't really understand it.
It's a bit complex, but basically it allows computations to be performed on encrypted data
Okay.
without having to decrypt it first.
So you can analyze data without ever actually seeing the data.
That's the idea.
Wow. Okay, are there any other techniques?
Yes, we have confidential transactions,
Okay.
which hide the details of a transaction, like the amount,
Okay.
but still allow it to be verified on the blockchain.
So you can keep the details of a transaction private,
Right,
but still prove that it happened.
exactly.
Okay.
Then there are stealth addresses, which generate a one-time address for each transaction.
So it's harder to track the transactions.
Exactly.
Okay.
And finally, we have hybrid networks,
Okay.
which combine public and private blockchains.
Okay.
So sensitive data can be kept on the private blockchain,
Okay.
and less sensitive data can be on the public blockchain.
So it's kind of like a best of both worlds approach.
Exactly.
Okay, so it sounds like there are a lot of ways to enhance privacy on the blockchain.
There are a lot of smart people working on this.
Okay, good.
And it's crucial because privacy is really important,
Yeah, absolutely.
especially as blockchain becomes more widely used.
So now let's talk about security,
Okay.
because no system is perfect,
Right.
and blockchains are not immune to attacks.
They are not. No system is 100% secure.
So what are some of the key security risks?
Well, it depends on the type of blockchain.
Okay,
So public blockchains like Bitcoin and Ethereum,
okay.
they face the risk of double spending attacks.
Double spending attacks, what is that?
That's where someone tries to spend the same cryptocurrency twice.
Oh, okay.
They try to send the same unit to two different people.
So that would be bad.
Yes, it would undermine the whole system.
Yeah.
But consensus mechanisms like proof of work,
Mhm.
they're designed to prevent that.
Okay, so the same mechanism that secures the blockchain also protects against this type of attack.
That's right.
Okay, what about other attacks?
Another one is the 51% attack.
Okay, the 51% attack, I've heard of that.
Yes, this is where someone gains control of the majority of the network's computing power.
Okay, and then they can basically control the blockchain.
Right, they could reverse transactions or prevent new ones from being confirmed.
So that sounds pretty catastrophic.
It would be, but it's extremely difficult to do.
Okay.
Especially on a large blockchain like Bitcoin.
So it's not very likely.
Not very likely, no.
Okay, what about private blockchains?
So private blockchains are often used by businesses,
Okay.
and they face different risks,
Okay.
like user privacy breach.
Okay, so even within a private network, there's still a risk of someone accessing data.
Right. It's important to have strong access controls and encryption.
To protect that sensitive information.
Exactly.
Okay, and then there's also the risk of cyber attacks.
Yes.
And network intrusion.
Right.
So this is where someone tries to exploit a vulnerability in the system.
Exactly. They could try to compromise the blockchain itself
Okay.
or steal data.
So are there any general best practices for security across all types of blockchains?
Yes, definitely.
Okay.
Secure key management is really important.
Yep.
So making sure that users protect their private keys.
Right, because that's like the key to their wallet.
Exactly.
Yeah.
Another one is security audits.
Okay.
Having experts review the code to find vulnerabilities.
Okay.
And user education is really important as well.
Okay, so teaching people about security best practices
Exactly.
and how to protect themselves.
Right. Because ultimately, security is everyone's responsibility.
Okay, so this has been a really great overview of blockchain security.
I hope so.
It's a complex topic,
It is.
but I think we've covered a lot of the important points.
I think so too.
Now, before we wrap up, I want to talk about one more thing.
Okay.
Hyperledger.
Hyperledger. Yes.
I've heard of it, but I don't really know what it is.
So Hyperledger is an umbrella project
Okay.
hosted by the Linux Foundation,
Okay.
and it's aimed at advancing blockchain technology for businesses.
So it's not a single blockchain.
No, it's a collection of frameworks and tools
Oh.
for building blockchain networks.
Okay, so it's like a toolkit for businesses.
Yes, exactly.
Okay, so what are some of the key Hyperledger frameworks?
Well, one is Hyperledger Fabric,
Okay.
or HLF.
Okay, Hyperledger Fabric.
This is a permissioned blockchain framework.
Okay, so not everyone can join.
Right. Participants need to be authorized.
Okay.
It's very modular and flexible,
Okay.
and it supports private channels,
Okay.
so you can have confidential transactions between specific participants.
So it's really good for businesses that need privacy and control.
Right. Exactly.
Okay, what else?
Another one is Hyperledger Sawtooth,
Okay.
or HLS.
Okay.
And this focuses on parallel transaction execution.
Okay. So it can handle a lot of transactions at the same time.
Yes, it's designed for high throughput,
Okay.
and it's often used in IoT applications,
Okay.
where you have a lot of devices exchanging data.
Okay.
Then there's Hyperledger Iroha,
Okay.
or HLI,
Okay.
and this one is known for its simplicity,
Okay.
and it's often used for things like asset management
Okay.
and identity management.
Okay.
Then we have Hyperledger Indy,
Okay.
or HLIME,
Okay.
and this is specifically for managing digital identities.
Okay.
So it allows people to control their own data.
Okay, so like a self-sovereign identity.
Exactly.
Okay.
Then there's Hyperledger Burrow,
Okay.
or HLBU,
Okay.
and this is for executing smart contracts.
Okay.
It's compatible with the Ethereum virtual machine
Okay.
because you can run Ethereum smart contracts on it.
Okay.
And finally, we have Hyperledger Besu,
Hyperledger Besu.
or HLB.
Okay.
And this is an open source Ethereum client
Okay.
that works with both public and private networks.
So it's pretty versatile.
It is, yes.
Okay. So it seems like Hyperledger has a lot to offer businesses.
It does. It's a very active and growing ecosystem,
Yeah.
and it's really helping to drive the adoption of blockchain.
So as we wrap up this deep dive,
Okay.
I want to ask you about the future of blockchain.
Okay.
What are some of the challenges and trends?
Well, one of the biggest challenges is scalability.
Okay.
A lot of blockchains, especially public ones,
Mhm.
they can't handle a lot of transactions very quickly.
So that's a bottleneck.
It is, yes.
Okay.
So there's a lot of research going on
Okay.
into ways to improve scalability.
Like sharding.
Yes, sharding is one technique,
Okay.
and layer 2 solutions are another.
Okay.
And these basically try to move some of the transactions off of the main blockchain.
Okay, to make it more efficient.
Exactly.
Okay. What about other challenges?
Regulation is a big one.
Okay, yeah.
Governments are still figuring out how to regulate blockchain.
Because it's such a new technology.
Exactly.
Yeah.
So there's a lot of uncertainty,
Right.
and that can be a barrier to adoption.
Okay, but despite those challenges, there are also a lot of exciting trends.
Oh, yes, absolutely.
Okay. Like what?
Well, one is the convergence with other technologies.
Okay, so blockchain working together with things like AI and IoT.
Exactly. It's about creating these synergistic ecosystems.
Okay, so can you give me an example of that?
So blockchain and AI can work together
Hmm.
to enhance data security and automate decision-making.
Okay.
And blockchain and IoT can work together
Okay.
to track and manage data from connected devices.
Okay.
And 5G networks will make blockchain applications even faster.
So it's all about connecting everything.
It is.
Okay, what other trends are there?
Another big one is adoption.
Okay.
Blockchain is being adopted by more and more industries.
Okay, like finance,
Yes, finance, supply chain management,
healthcare,
and it has the potential to disrupt many other industries as well.
like voting,
Yes.
real estate, intellectual property.
Exactly.
It seems like blockchain really is the future.
It has the potential to change a lot of things
Yeah.
for the better.
So this has been a really fascinating deep dive into blockchain.
It has been very interesting.
We've learned a lot.
I hope so.
So I want to leave our listeners with a question to think about.
Okay.
What aspect of blockchain technology do you think has the most potential to change our society?
That's a good question. I think for me, it would have to be the way that blockchain can redefine trust.
Trust.
Because blockchain allows us to establish trust
Okay.
without having to rely on traditional institutions.
It's like a new form of trust.
Exactly. And I think that has the potential to change everything.
Yeah, I think you're right, because trust is really the foundation of so many things.
It is.
So if we can find new ways to build trust,
Right.
that could have a huge impact on our society.
I agree.
Well, this has been a really great conversation.
It has.
Thank you for joining us today.
It's been my pleasure.
And to our listeners, thank you for tuning in to another deep dive. We'll see you next time.